Hey there, folks. It is November 2nd, and we are looking at, we're going to look at rivers and streams today, water. Chapter, not sure what chapter it is. But anyway, it's, but anyway, yeah, I'm looking at the thing here, but I'm going to have to knock me at chapter 17. Sorry about that. Uh, there we go. So, yeah, we're looking at chapter 17. But we're looking at rivers and water as a hydration, as a hydraulic system. This one is kind of important for what we're doing, mainly because we live pretty close to a big river, right? The Ohio River, and we living in Kentucky, we have lots of streams and rivers, so they have influenced and they have changed the landscape that we live in quite a bit. So they are kind of important, and so we will look at that in a little bit of detail. So let's jump right into chapter 17 here, streams and floods. So we know what rivers are, and then your book kind of goes into some little information in terms of parts of rivers. And these are important if you're trying to talk to someone about a river or to look at a river on a map, to understand the difference between a channel, headwaters, and the mouth of the stream, that sort of things. We kind of know what a flood is, right? A flood's when you have too much water for a river to hold, and so therefore we get a flood. Again, Louisville's a city near a big river, so we have had some floods in the past, have had some not fairly recently. So we do still get some floods, not as bad as we did in the past because we've got systems in place now to mitigate a lot of the flood damage. And we'll talk about those here in just a little bit. But anyway, what do rivers do? What do streams do? Well, they essentially drain the land, don't they? We get rain, and that water has to go somewhere. A lot of that water, of course, soaks into the ground, but a lot of that water either it rains so fast the ground can't soak up the water, or maybe it's rained for so long now the ground is saturated, full of water, and therefore the water runs off. So this is what they mean by sheet wash. We'll talk a little bit more about water table, what about groundwater and a water table, but we'll talk a little bit about it in this chapter. Water table is that groundwater that's under the ground, and the water table is sort of the level of that water. So it's sort of like a little lake or a ocean under the ground where water reaches a particular level. Now, as it rains more and more, the water table goes up. As it gets dry, the water table can go down. So that can be what causes some streams to flood because the water table is very high. Again, the ground is very saturated. Or in the fall, where maybe this water table is pretty low, then you can get a lot of rain and still not have as much flooding. So that's kind of how this particular system works with water table. And again, we'll talk about that a little bit more in some of the other chapters. So runoff is that water that doesn't soak in and it runs along the surface. And as you know and have seen probably, that as it does so, it picks up sediment. So a lot of that water that's running kind of looks brown, dirty, and it is so because it is full of sediment. Of course, as it flows, if it's flowing quickly and there's a lot of water, it may pick up some large pieces of sediment. Those can fall out quickly, but the small, very small suspended pieces of sediment can stay in there for quite some time. So the water kind of looks dirty or cloudy, and that's the very small pieces of sediment. When we think about that sediment, we think about the Ohio River. The Ohio River always looks muddy, doesn't it? It always looks like there's a lot of sediment because there's a lot of sediment in the Ohio River. It's been picking up water from all kinds of streams all the way up into Pennsylvania. So it's got quite a bit of settlement. Any of the big rocks, any of the big stuff has settled out quite a long time ago. That's why, like in a mountain stream where you go up and you see the water's running quickly, it's kind of clear because it hasn't picked up all that sediment. But by the time you get to big rivers like the Ohio or the Missouri or the Mississippi, they always look muddy. They always are full of sediment because they're always carrying that sediment away. So this is erosion, right? This is the act of erosion, and this is what shapes what we see, isn't it? We see valleys, We see places where the water has flooded and made areas kind of flat. But anyway, this is what erosion does. So again, some language about what these what rivers are and what they have are things like tributaries, which are creeks and stuff that flow into bigger streams that have what we call the trunk stream. And so we have some bigger rivers in the state, like the Kentucky and like the Kentucky rivers is one I'm thinking of. The Salt River, things like that are more like trunk streams that have a drainage network. And a lot of these, a lot of this definition you don't have to pay much attention to, but do read it so you kind of understand what's kind of going on. So when we think about rivers and drainage, right, we think that up high on a mountain, right, that's where the rain may fall, but we don't have many streams or rivers up there. They happen farther down as the mountain is being drained. So have you ever thought that there may be a place where rain falls, and if it falls in one area, all that water will drain to one place, and if it falls in another, it'll all drain to a different place. These are what we call divides. And so this is a divide here in the United States, one of the divides, where if rain falls on this side of the mountain, these are the Appalachian Mountains, but if the rain falls on this side of the mountain, that water is going to end up in the Atlantic Ocean. And then if it falls on this side of the mountain, it's going to end up eventually in the Mississippi River and in the Gulf of Mexico. These are what we call continental divides. This is even a bigger one here out west, and this one's kind of neat because when we went out west, we stood right here on the continental divide, and we kind of joked that you could take a glass of water. There's a road there. You could take a glass of water and pour it on this side of the road, and all that water would eventually end up in the Pacific Ocean. And if you took another glass of water and poured it on the other side of the road, that water would end up in the Gulf of Mexico. So that's what divides do. They literally divide the drainage basin. So this is one big drainage basin here. All this area here drains into the Gulf of Mexico. And then individual rivers will have their own drainage basins. For example, the Ohio River in which we live has a drainage basin that all the water, if water falls somewhere, for example, if you were to spill water on the ground right now in Louisville, it would be in the Ohio River drainage basin. So it would go in, it eventually find its way to the Ohio River, and then eventually into the Mississippi, and then eventually into the Gulf of Mexico. So that's what we mean by basins, by drainage basins, and what we call watersheds. So we are in the Ohio River watershed, and the bigger watershed would be the Mississippi River watershed, because water would fall into that area, right? So those are kind of important because they are kind of big areas that do kind of some big things with water, and so it's good to understand how that works. Here you can see the drainage basin for the Amazon River, and you can see this it takes up almost an entire continent. Here you have the mountains, the Andes Mountains. So even though you were way over here on the mountains, just a few miles away from the Pacific Ocean, if you dump some water out, it would eventually end up in the Atlantic Ocean, having flowed all the way through the Amazon River. So they are kind of interesting when you stop thinking about them in that manner. Your book talks about streams, different kinds of streams, like permanent streams and what's called ephemeral streams. So ephemeral streams are those creek beds that you see usually up in the hills, up in the mountains, that are just a bunch of rocks. And it's obvious that there was a stream there, but the rocks are just there now, and there's no water that you can see. There's water under the ground, but you can't see it on the surface. And so these streams have kind of dried up. But they will respond in the spring or during flood times when water comes. Permanent streams always have water in them to some degree. And so that's what we mean by ephemeral and permanent streams. Now, out west, you get these areas called washes. And again, traveling out west, if you ever get a chance, you need to go out west. And these things are really cool. This looks like a stream, and it is, but there's almost no water in it. Sorry about that. All right. Anyway, getting back to what we're talking about. Shoot. Get back to my thingy here. Hang on. It's here somewhere. There we go. Talking about getting back to our stream. So anyway, these washes are out west, and again, they're dry all the time, most of the time, and then you'll get rain. Sometimes these things will happen that you don't even see the rain, and the rain will happen 50, 100 miles away. And these washes, because this area is so dry and the ground's so packed, there is almost no water table, and so the water runs along the ground. These washes can just all of a sudden fill up with water. So they are very interesting, but it can be in that area kind of dangerous. So anyway, we talk about the flow of streams. And again, this is some really interesting stuff, but it's not really super important. One of the things that is kind of neat, though, is to look at a river and understand kind of how it flows. I like to go canoeing and kayaking, so you want to understand where a river is, because if you're canoeing in a river, you kind of want to know where the deep part of the river is. Well, the deep part of the river is always going to be on the outside of this bend, right? Because on the inside of the bend, it's kind of flat, and you may have even a beach there. But on the outside, that's where the water is kind of forced out as it's trying to make a turn, and so it eats away at the rock there at the surface, and so that's usually the deeper water. And you can see that in all kinds of streams, even the Ohio River. If you go out and look at it where it makes the big bend around Louisville, on the Indiana side where it makes that big bend, it's really steep and deep, whereas on the Louisville side, it's kind of flat, and you even have little beaches. So it happens even in big streams. So there's all kinds of stuff that can happen. You can have these whirlpools, and boulders and rocks will have a big impact on how the water moves. So again, this is erosion, right? The streams are transporting sediment, and again, depending on how much water, the speed of the water, all that sort of thing, can depend on the load that the stream is carrying. So if you've got a lot of water moving quickly, right, then you can pick up some pretty big rocks and move them from one place to another. But if the river has a lot of water but is moving slowly, maybe it's reached a kind of a flat area where it's moving, like the Ohio River. I mean, it's pretty flat around here. The river's still moving, but it's not carrying great big rocks anymore. Now it's just carrying very small sediment. And here again is a good picture of that. Here we see the water's kind of clear, and then on a rainy day, it's picking up this sediment and moving. And here you can even see that sediment as it's being deposited out into a lake or an ocean, right? And so this again is literally erosion in action. You can see pieces of rock or pieces of soil that are being carried out. So do streams change? Do rivers change? Yes, they do. You can look at a map or look at a picture, an aerial picture of almost any river, including the Ohio River, and see how that river has changed over the years. You can have kind of a low point, and the river will follow a certain course, but then you might have a flood, and the river kind of short circuits that course, and then it literally changes course, and maybe even cut off part of the river. And here you can see a map of kind of how that whole system works, where you have trunk streams, and finally the main river itself, as it comes into a floodplain, it begins to what we call meander. The river slows down, so that's kind of where we are in the Ohio River. We're kind of meandering, aren't we? And the river kind of snakes its way through the landscape. But let's look at, yeah, there was a picture here a minute ago I was going to show you. See if we get to it. Well, before we do, you can see how the water cuts through different kinds of rocks. So really, it depends on, as much of the river, it depends on what sort of rock it's going through. So, for example, we see the Grand Canyon, right? And if you look at the Colorado River, which runs through the Grand Canyon, it's really not a very big river. It's really actually just a kind of a run-of-the-mill river. It's certainly much smaller than the Ohio River. And yet it's carved this incredible canyon over 6 million years. Why wouldn't the Ohio River carve the same kind of canyon? Well, it's obviously because of the uplift. That particular area of rock and sediment has been lifted up in the air over a mile And so as the river is moving, it's cutting down through. Now, the Ohio River cuts through our landscape, but it's not been that area has not been lifted up, so it can only go so far before gravity would literally stop it. So it depends on, as much, again, it depends on what the soil and conditions are, the rock conditions are under a river, as it does with the amount of water and where that water is going. Again, your book talks about different sort of forms, landforms we see. So as the river is depositing material, we see something called an alluvial fan. It literally looks like a fan, right? We normally see these where the river deposits its sediment into maybe an ocean or a lake or something like that. They're pretty obvious, but you can also see them in an area here where you can see the river coming down, and here's the big fan where that material has been deposited over many, many years. We've already talked about streams and rivers when they begin to meander and can change course. Here we can see streams where we drop in this, what causes waterfalls. And so these are all part of river systems. So here's the Niagara Falls, which is a very interesting river. This is the Niagara River. And the Niagara Falls is literally draining all the Great Lakes. So all the Great Lakes, Ontario and Superior and Michigan and Erie, all of them are being drained literally through this one little channel and over this particular outcropping of rock. And so this erosion has been happening over just a few million years, not very long actually. But here you can actually see a photograph in the 1960s when the water was diverted. You can see what that the Niagara Falls looks like with no water. But you can see how this works. As the water is falling, it's beginning to undercut the softer rock, then the harder rock will break off, and the whole thing begins to move back. So it's literally the falls have moved several miles from where they originally were over just a few thousand years. Here are those meanders we were talking about. And so here's a river that's been meandering, right? This looks very familiar, like this could be somewhere in Kentucky. But here you can see literally the river has changed course. Here at one time, the river went through here and actually went around here and then back. But for some reason, there may have been a flood and this flooded over. And so it literally cut off all this area, which becomes what we call an oxbow lake. Here you can see it down here in the picture. These little lakes called oxbow lakes. Here we see another one where at one time the river channel went like this, right? And then at some point in time there was a flood, a lot of water. The water kind of broke over that because it's a little quicker to go this way than that way, and cut off that particular part of the river. So you see these all over the place. Here you can see some here, and then we'll look at some photographs a little bit later where you can they're just, here we go. This is actually in Brazil, and I think it says a meandering stream, so it's not the Amazon, but you can see the stream. So you can just see these where this thing is just moved all over the place. These lakes are just all over in place and just look like little snakes all over. So the river has moved quite a bit over time. Here again are some pictures of what happens to the rivers when they finally get to a destination, like a lake or an ocean or something like that. So here we can see a pretty famous place. There is New Orleans, right? This is Louisiana. This is where the Mississippi River dumps all of its sediment. And so when you actually look at a picture, when you actually look at the map of New Orleans, you can see where New Orleans was, right? Let's see if I can get to it. There we go. You can see where New Orleans, where the coastline used to be, but over thousands and thousands of years, literally, there's literally hundreds of thousands of acres of sediment that's pushed that state out into the Gulf of Mexico. And here we can actually see, we can go back and look at the sediments and find out when those particular sediments were put down. So these sediments here were 7,500 to 5,000 years ago. And then, as you can see, all the way up to modern New Orleans. So New Orleans is literally built on sediment. It's built out in the middle of the Gulf of Mexico on sediment that probably used to be in Nebraska or Kansas or someplace like that. So this talks about how these can change. Here we're looking at the tectonic action, plate tectonic action, of how the river actually changed directions here. South America used to have a river going this way when it was connected to Africa. As soon as it moved away from Africa, the mountains got pushed up and the river went in the opposite direction. We actually have a very interesting story about the Ohio River. The Ohio River used to be two rivers, and they started up in Indianapolis. And in the last ice age, about 20,000 years ago, is when the river was pushed down here and became one river. And that's kind of why here in Louisville, we're sort of living on, you're actually built on top of a bunch of uh, debris pushed here by the glaciers. And the river was kind of just pushed along with all the junk. So it's pretty amazing the power of glaciers and things like this. So they can move rivers, they can change rivers, all sorts of stuff. Um, Now we talked about floods a little bit. Of course, we know a flood is when there's just too much water for the river to carry, and so that water goes out of the river onto the land. And again, here in Kentucky, we see lots of floods since we have lots of rivers. The bigger rivers have sort of been tamed by dams. There's quite a few dams on the Ohio now that help to control flooding. Plus, we have the flood walls. We'll talk about those in a little bit more detail. But some of the smaller rivers still flood quite a bit. And so you get these areas called bottomland where the river floods. And when it floods, all that sediment comes up on the land. And when the river recedes, all that new sediment stays. And this is what farmers used to use for fertilizer. And this goes back thousands of years. It was done in the Nile River for years and years. And of course, it was done in Mesopotamia with the Tigris and Euphrates River. That's why agriculture literally started in that area, is because you could grow crops there. And as the river flooded, the flooding river would sort of replenish the soil and you could grow more crops. Of course, today we understand why that is, and we can use fertilizer and sort of take the place of flooding, but in a lot of areas it still happens. And people use that again as a way of growing food. So some more pictures here. Whoops, I've got something messed up. This computer does weird stuff. Here's that really big map at the end. It's really nice to look at. So put that in your notes. Flash flooding, of course, is when you get a lot of water over a very quick period of time. This doesn't happen in big rivers like the Ohio. The Ohio, we usually know the flooding happens over days because there's so much water. But flash flooding can happen in smaller streams and rivers in a matter of minutes. These are stories of people who it's been raining and raining and raining, and all of a sudden the water starts coming up and it's moving. It's coming up a foot every minute, and these can be very dangerous because they happen very quickly. Story here about the Jonestown flood, which happened because of some human hubris, but all the same, it was a flood and caused quite a bit of damage. Um, Again, how do we deal with floods here in Louisville? We have these flood walls. You've seen these downtown. So this is a flood wall in Missouri, but we have them here in Louisville. And so what you do is when there's a flood coming, you'll put these gates up. And you may have remembered a few years ago, the gates were used, and we have these dikes. If you've been over in Indiana, you know there's a big dike here. If you've been in southwestern Kentucky, you know, or southwestern Louisville, excuse me, we have these big dikes that help to control flooding as well. So this is how we've sort of tried to fix the problem. Some people would argue it causes more problems than not, but especially if you live downstream, like poor Louisiana, you can see here where they've had some issues with levees breaking and flooding problems. So a levee that was built and was supposed to hold water back, when it breaks, it's even worse. So this is still a bit of a problem. And now with climate change, where some areas are getting more water than they ever have before, flooding could be even worse. So we're going to talk about that in the last couple chapters, but climate change kind of permeates almost everything we're talking about from now on. And water and flooding, we see this every spring, right? It gets worse and worse and worse. And then in other areas, rivers are just disappearing, aren't they? So some areas, because of climate change, are getting more rain. Others are getting less. And so the rivers are literally disappearing. So, for example, and to the fact that a lot of this is happening out west, places like Los Angeles don't have enough water, so they're sucking water away. Here's the water being sucked away from the Colorado River going to Phoenix, miles and miles away. This is literally a big tube of water being sucked away from the Colorado River, which, interestingly, if you go there now, you can go to the Colorado River and see the river in the Grand Canyon. But by the time the river gets to the ocean in Baja, California, by the time the river gets to the ocean, there's no water left. Everyone is taking water and taking water and taking water. And so now the Colorado River literally doesn't even go to the ocean anymore. So it's pretty amazing. Good reading in this chapter, so please read it. It's very interesting, especially living in this area. Here's your review questions. Looks like there's quite a few to choose from. So if you're going to do some for this chapter, feel free to pick some good ones. And I will see you next time.